Hello.
Morning.
Good
Can you
morning.
hear me okay? Can you hear me
Yep.
well?
It's all okay.
All right, cool. So I understand you're the only one here, so we're going to wait for some other people for another 5 minutes, and then we're going to start. Okay?
Okay.
Right. So good morning.
Morning.
Can you hear me okay?
Yes, I can hear you well.
All right, cool. So we're waiting for another 4 minutes, and then we're going to start the class.
Okay.
Okay.
May I ask you,
Sure, go ahead.
is it crucial to fit within 5 minutes? Because I've realized that it's not possible for my case.
Well, with the presentation, it's 8 to 10 minutes.
8 to 10. But no, wait a second. You said that 8 to 10 minutes. Those are limitations for the main exam in autumn, right? So, but today we have a limitation of 5 minutes.
Yeah, that's true.
Yeah, but no, I'm just saying that I have problems with this limitation.
Oh. So what's the question once again? So you said that you cannot. Go ahead.
Is it crucial that I cannot fit within 5 minutes?
What do you mean? You like, are you like going overtime?
I guess I require 6 or 7 minutes, something like that.
That'll be fine.
Okay.
Okay. Alexei, Hamna, can you hear me okay?
Yeah, I can hear you well.
Okay, great. Hamna? Hamna, can you hear me?
Can you hear me?
Yeah, we can now.
I was saying that I have a request. I would have to leave the class earlier because I have this exam and I really need to be there.
There's no problem. We could start with you, actually.
Great. Okay. So
sorry, Hamna, what exam do you have? Just in case if it's not our exam too.
no, don't worry. It's just I'm a TA of the course Artificial Intelligence, and we have this exam at 10, and so I need to be there just to, if students have any questions or anything.
Sure.
I see.
So can I share? Yeah.
Hamna, is it university course?
I didn't hear you. Can you repeat?
Is it University of Annapolis course?
This is not related to candidate of science program. This is just usual course I'm a part of as a TA.
Okay.
So you're going to give the exam, right?
Yeah, exactly.
Not to take the exam.
Exactly. Yeah.
All right. I think we're going to start now. So the plan for today is for you to give your mock presentations, and I'm going to listen to those and give you some feedback. And today is going to be your last class. After the presentations, you will have a chance to ask any other questions that you might have, and then they'll be all for your PhD English exam preparation course. So since Hamna is in a hurry, obviously, we're going to start with Hamna. Okay, here's the deal. Hamna is going to speak. Hamna is going to deliver her presentation. And I would want everybody else to listen and to ask at least one question to Hamna after the presentation. Do you understand what we're going to do?
Yes.
Yes.
Alexei?
Yes.
Okay,
I
cool.
think switch.
Right, that's okay. So please, when you're listening, be sure to take notes. All right. So don't forget that your presentation should consist of the introduction, the body, and the conclusion. Don't forget about that. Right. So Hamna, you can start.
Okay, so I will share my screen. Let me
And
know.
yeah, sure, Hamna. And could you turn on your camera, please?
Yeah, sure. Okay. Can you look
Okay,
at
cool.
me?
Yeah, we can see you. Right.
So I never shared screen before. So I need.
It's a presentation, so you kind of
Yeah.
have to.
So can you see my screen now?
Not really.
But I shared actually. I don't know what to do.
Okay. Might want to try it again.
I am sharing, but for some reason, can you see now?
No,
That is so strange.
it's kind of
So
strange, yeah.
I'm
Did you use the share button with the
exactly.
arrow?
Yeah, what I'm doing, I'm pressing this button and then I'm maximizing my slides. But for some reason, you cannot see my slides. I don't know why.
You should see another window showing what are you going to share, like the desktop or any other kind of window. Do you see it?
Yeah.
And you should.
Can you
This is
see?
more.
It's loading. Yeah, we can see it now.
But for some reason now I'm trying to turn it to, okay. So you can see everybody?
Yep, I can. Guys, how about you?
Perfect.
Yes.
All right, cool.
Okay. So my name is Hamna Aslam and I am a PhD student in Artificial Intelligence and Games Development Lab. And I will give you some overview of my PhD research and what I have done so far. So broadly, actually, I titled my thesis as Affordance Theory in Game Design because I think this title like pretty much covers everything which I'm doing in my research. The word affordance, it means how we interact with any object or how we interact with the environment. And for the particular analysis, I have chosen the object which are like analog games. So I try to understand what is a good game design, what is a desirable interaction with games. Significant feature or the significant reason for selecting games as my topic is that games are being used for several purposes, for education, for training, for medical analysis, and many other things. And I think that there is a need to investigate what is a good game design so that it serves the purpose it is intended for. So what are the benefits that people will have with my research? I'm trying to decrease the cognitive load, not just of the player. Like I want them to have desirable interaction, so it will decrease the cognitive load naturally. But I also want to decrease the cognitive load of the designer, because if they have some idea of the impact of human factors on the desirability of the interaction, they will be able to design better games. And naturally, if for the affordance investigation, we are taking into account human factors, and it would increase the or promote the usability of the project, and we will be able to cater as many users as possible. Okay, I have initiated a scientific methodology. What does this methodology do? I do a lot of user testing, and then after the user testing phase, we interview each user through audit questionnaire methodology. Then the bigger part comes, we analyze the data, we categorize our data, and then we do statistical significance testing, and then we see if our hypothesis, whatever we are investigating, we could prove or we could disprove, or any significant result. I was telling you that I do research on human factors. So there are many human factors, and gender is one of them. So what I did in one of my experiments, I took into consideration the human factor of, age. Actually, I cannot see my slides, my own slides fully. So first, I took into consideration age, and they were participants from 3 age groups. And what we did, I presented them the game. They were not familiar with the game at all, and I was trying to analyze how they interact with the game. And in their interaction, what are the commonalities and what are the big differences? At which part they felt frustrated or annoyed, or they have to pay a lot of attention, something that was not clear. So everything I did. And then by we, I mean that with my supervisor, we categorized the data. And you can see that I highlighted several points in which we could clearly see the difference between either like 3 groups or 2 groups. Then moving on, I also considered the human factor of gender. So naturally, the participants were males and females. And in this, I could not see much difference between how they interact with the design, but there is just one thing which is highlighted here. You can see that, so the game is about goblins, and there were some stones. And I could see that none of the boys, they said that stone is a friendly object. They were considering it an enemy. And you can see from the statistical test that there is a significant difference, that the girls were considering it an ally, a friendly object, because they were saying that we play football with it probably. So this was the significant difference in this aspect. Then I also try to understand player perceptions about design in terms of various aspects. I try to analyze how they prefer a particular object or a particular design based upon the fact if they are familiar with the object or not. So in this case, you can see in front of you, there are 2 types of dice sets. One is on the left, it's a very common set, and on the right, actually it's a new set, it's called wizard set. And we had participants who were familiar with, some participants were familiar with the wizard set and some were not. And the analysis shows that the ones, usually people prefer in general things they are familiar with already. This is one of the outcomes of this research. And I also try to examine the impact of color. You can see different dyes in front of you. It was a huge experiment, but I'm just sharing one of the results. On the top, you can see opaque dye, and it's like white background, black dots is the most common one. And you can see there were no errors in reading this dye, and there were no confusions, but with rest of them, there were some confusions or errors, like especially which is on the third one. It is transparent. First, it is transparent, and the color contrast is like, I would say, not very good. White dots on a transparent dye. So you, as you can see from the table, it's like 26 times people were confused just reading the outcome. So just because of time limitation, I'm just sharing one little outcome from my each research. All these experiments are still going on. I'm still analyzing the data, still conducting more research. And what I have done, I have published all these results in my book. This is the title of the book, Affordance Theory in Game Design. And there is a link if you are interested in reading the book. All experiments are listed there in detail, all the results, which statistical test I have used, and how we have analyzed the data, research outcomes, everything is published in the book so far, and still I'm continuing the test. You can ask me any questions if you have.
Thank you so much. Gentlemen, one question from everybody, please.
Is it like some kind of a combined analysis of psychology of players, and at the same time you apply statistical analysis? I mean, you apply statistical analysis on, I don't know, on those results, and thus you derive some. I mean, thus you derive some conclusions, right? So that's the overview of your research, right?
So about psychological analysis, yeah, whenever we are studying human beings, the psychology is always involved, but psychology is not my major. So I try to take into account psychological concepts, but I can say that my research is along the lines of human-computer interaction, the way you understand how human beings are interacting with any software or any feature of the software. The same way I just try to understand how they're interacting with analog game designs. And yes, there are confusions, there are results, like whatever we infer from the research outcomes.
But how do you how do you analyze this interaction? Do you give them some kind of questionnaire so they can answer
Yeah, so first there is a whole test in which they are interacting with the design, and every time whenever I do any test, I make sure that they are not familiar with the game or any rules or anything, because then I cannot get authentic results. So I present them the game, and if they are not familiar with it at all, then we proceed with the test, and then they fill a form. Then after that, I also conduct oral interview. So I ask different questions about each aspect of the design, and then also they write down the rules, mechanics, whatever they understand can be the rules of the game. So they write down their interpretation, and then I try to see the intersection between what they have written and what are the actual rules of the game. And whatever is not in the intersection, it means that the design could not afford this action to the player. So the designer need to look into this.
Thank you.
Welcome.
Thank you, gentlemen. Artur,
Yeah. Is your research already applied to any kind of games? Like, does it has some practical application?
Okay, so I have tested games like Hanabi. It's a very, very popular game, especially from research point of view. People have developed even AI players for Hanabi. So Hanabi, Love Letter, Goblin Dice, all these games I have investigated. I have published the results too. If you're asking in terms of if I have contacted a designer specifically and informed them about my research outcomes.
Yeah. The question is, did it affect like the development of new games or creation of new games in a way that transforms this?
Actually, so this is the reason we published the book, because we want game designers to know about it. We do publish research papers, but book has a broader community audience in terms of like reading. So we have published the results in the book, and now since it is published, now we want to like inform everybody about, especially the designers of those particular games which I have tested. So this is like now what I will do recently.
Thank you.
Thank you. Artur?
Okay, Hamna, hello again. How you think? What will was next step your research? Next iteration, next way your research?
Okay, so the next important step is to do more testing, because with this sample size, I don't think that many people can be convinced that the outcomes are very authentic, because whenever we are involving human beings, we really need to test as many people as possible. So I'm trying my best to reproduce the same experiments and increase my sample size, and then understand if the results which I already have, they hold true for further experiments also. Then it will make them more authentic.
Yeah.
Thank you so much. Thank you. Hamna, you can stop sharing your screen. Thank you.
Okay.
And comments. I don't really have lots of comments. That was quite a good presentation, I should say. Just one thing. First of all, you were slightly over time. The time limit was 5 minutes, and you went for 7 minutes. So you might want to pay attention to that, during the real exam presentation. So it's 8 to 10 minutes, and you might want to aim at 8 minutes. Okay, and you might want to practice that a lot, so that you're within the time limit. That's one. Another thing is it's about the structure. You might want to have a more rigid structure, if I may say so. So it's like basically it's like repeating things. Okay. So the introduction, the body, and the conclusion. In the introduction, you have to say, I'm going to speak about this, this, and that. And with the body, you actually speak about this, this, and that. So you might want to have like 3 main points for your body and concentrate on those. And in the introduction, you should mention those 3 points. Like for example, in the introduction, you might want to say, I did that research concentrating on dice color, dice shape, and I don't know, something else. Okay. And for your body of your presentation, you would have to say, I'm going to start with the color, then you will speak about the dice color, and then you will say, we're going now to move to the dice shape, okay? And to the last point. And with a conclusion, you have to repeat those things once again, saying, so I've researched the influence of dice dice color, shape, and something else on like game procedures, and I got those results. Okay, so if you structure your presentation like that, it will be easier for the committee to listen to that, and chances are that you will get better grades because the committee will be looking for the structure.
Okay.
So, and another thing, the last thing actually, it's about introducing yourself. Basically, you will not have to do that because everybody will know that you are, I mean, everybody will know who you are. So you might want not to waste your time on saying your name and your position
Yeah.
so you might want to, you know, cut straight to the chase, start with the presentation, like I'm going to speak about this, and actually speak about that. Right, I don't have any other comments. Ask me questions, please. Hannah?
Okay, so I think I understood all the feedback. Thank you very much.
Mhm.
Just usually when I'm presenting, I don't realize, but I think I speak too fast. Was it okay? Could everybody understand everything?
If you could slow down a bit, there'll be a help.
Okay.
Because basically, when you speak too fast, it never helps the perception. It never helps the listeners to understand the presentation well.
Okay.
So you might want to pay attention to that too.
Sure. Well, thank you very much. I think I don't have any other questions.
Okay, that's cool. And Hamna, if you need to go, you're free to go. Thank you.
I think I will leave in like 15 to 20 minutes because my exam starts at like 10.
Sure, no problem. Thank you. Right. So we did Hamna, now Sergey, Artur, and Alexei. Who of you would want to be the next one?
I can.
Yeah, Sergey, go for it. Okay, guys, you're going to listen to Sergey, and please take notes and ask at least one question. We can see your screen now.
Yeah, 1 second. So can you see everything well?
I can, guys. How about you?
Yes.
Okay, cool.
Okay, so my presentation is going to be about molecular modeling methods. It's a fast developing branch of modern science, and it has a wide range of applications to computational chemistry, drug design, computational biology, and materials science. And one of the main study subjects of molecular modeling is solution. And here by solution, I mean a mixture phase that consists of solute and solvent molecules. And usually solvent molecules are more abundant. And to avoid explicit simulation of solvent molecules, because I mean, there are many of them, people came up with implicit salvation models such as PBSA or GBSA, Poisson-Boltzmann salvation area, and generalized Born salvation area. And generalized Born salvation area is one of the most frequently used implicit solvent models. And it requires Born radii pre-calculated for every possible spatial distribution of atoms. And in our work, we are trying to solve the following problem. How can we efficiently pre-calculate all Born radii for all possible mutual orientations of the complex of two or even more moderately or rigid or moderately flexible solid molecules. Okay, let's start with a short introduction about implicit solvent. In implicit solvent models, we represent solvent molecules as continuous media, and essentially you immerse solid molecules in this dielectric media. That's how it works. That's how you calculate the interaction energies. The main quantity that we're interested in, mostly interested in, is salvation-free energy. And salvation-free energy is released once you, is released upon transfer of the solid molecules from gas phase to the condensed phase or solution phase. Usually, solvation-free energy is decomposed into two contributions: non-polar contribution and polar contribution. Non-polar contribution is pretty easy to calculate because it correlates well with solvent accessible surface area, which is easy to calculate again. But polar contribution is much harder to calculate because, I mean, the most honest and the most accurate way to calculate polar contribution is to solve Poisson-Boltzmann equation, which is nonlinear elliptic partial differential equation, and that is really hard to calculate. I mean, really hard to solve such kind of equations. So people came up with an approximation which is less accurate, but at the same time less complex. That is GBSA, generalized Born solvent accessible surface area. In GBSA, we represent polar contribution as a sum of Coulomb-like terms. Each of them has partial charge, Qi, which can be calculated from semi-empirical quantum methods, dielectric constant epsilon, and FGB. FGB is expression of steel. You can see this expression on the screen. It's written in terms of inter-atom distances and Born radii. So the only parameter that we need to know is Born radii. So we need to pre-calculate this Born radii. So how can we do it? How can we do that? The first way is the honest way, again, to solve Poisson-Boltzmann equation, but that is not our way, as I mentioned before. The second way is to use Coulomb field approximation, or CFA. Essentially, so here you can see, for example, the solid molecule. You can see atoms, bonds between them, exterior of the molecule, interior of the molecule, and border between them, which is solvent excluded surface. So if you want to calculate Born radii from this approximation, you need to calculate integral of kernel G function over the exterior of the molecule. The problem here is that, as I said before, Born radii depends on spatial atom distribution of atoms, and so that means that you have to recalculate Born radii for each possible conformations. That's not possible. And one way to solve not the whole problem, but maybe some important sub-problem, that I've mentioned before. So that is the main result of my work. So how can we do that? First of all, let's, for simplicity, consider only two molecules. Let's assume that molecule B is fixed. Let's assume that we can translate and rotate molecule A by application of operator L. Here you can see L, which consists of a rotational part D operator and translational vector T. So how can we calculate? How can we recalculate Born radii? So let's write CFA integral that we have seen before. Let's decompose it into three integrals. The first integral is integral over the whole space minus integral over the interior of molecule A minus integral over the interior of molecule B. I cannot go much deep into details, but integral 1 and integral 2 do not depend on application of operator L. So they are absolutely the same. And they can be efficiently pre-calculated, as have been shown in Tsai et al. Paper. So then we have to only calculate integral 3. Let's rewrite it in a little bit different format. So let's introduce indicator function f. It equals 0 if R is outside of the molecule B, and it equals to 1 if R is inside of the molecule B. Then we can rewrite the third integral as integral over the whole space, and it's a convolutional like integral. It's a multiplication of indicator function and kernel function. Now let's apply the operator L that we have seen before, and let's change also the variables. Now the third integral has absolutely the same form, but here you can see that f function is rotated and g function is translated along the z-axis. So the main idea here now is to expand both functions, f function and g function, in terms of spherical harmonic, complete basis of spherical harmonic functions. So let's do it first for f function, then we will do it for g function. For f function, of course, we can decompose, and real nice feature of spherical function is that we can also decompose rotated f function, and new coefficients are related to the previous coefficient in a linear fashion. That's a really convenient, that's really convenient relationship. And the same we can say for g function. We can expand g function in terms of spherical function, and we can also expand translated g function in terms of spherical function. And again, there is a linear relationship between the coefficient sets. So now let's substitute both expressions, both expansions into the further integral. And here we see the final result. Sorry again for being fast. So what's really good about this final expression is that you see here you can see the red expression, the first one. It can be pre-calculated. We don't need to calculate it each time for every system. It's system independent, so it can be pre-calculated once and for all and stored somewhere. And another thing is that on the right-hand side of the screen, you can see a two-dimensional fast manifold Fourier transform, which can significantly speed up the whole process. So to conclude, we have reviewed Poisson-Boltzmann, generalized Boltzmann implicit solvation models. Then we have looked at Coulomb field approximation to Born radius calculation, and finally we theoretically derived an efficient FMFT fast manifold Fourier transform based pre-calculation algorithm, and we believe that this algorithm can significantly speed up a wide range of implicit solvent solution simulations in computational chemistry, in computational biology, and maybe drug design. So yeah, that's all I have. If you have any questions, I will be happy to answer them.
Thank you so much. Guys, questions, please? Hamna, we can't hear you.
Okay, who is your supervisor, Sergey?
Yaroslav Holodov.
Okay, I would like to know which software techniques or tools you are using for your research.
OpenFFT, just the standard fast Fourier transform library, and the rest of this thing, I guess, yeah, we are writing on our own. That's our in-house developed code. But this part of the code is not developed yet. Sorry, but it's in progress.
So later it can happen that if you share your code, people will be able to put their own values and calculate it. Is it, am I right?
Yes, totally. It's, again, so this is just a description of the method. Of course, you can apply this method to any kind of system. If several conditions are satisfied, first, you are dealing with implicit solvent solutions, and solid molecules are moderately flexible. Then yes, then you can use this fast pre-calculation of Born radii.
Okay, that was the only question. Thank you.
Mm-hmm. Thank you, Jens.
Okay, I'm trying. It's very far from me, but I'm trying. Sergey.
Yes.
As I remember, the Born model of atom theory is not quite consistent and general, and modern science using quantum mechanics in research. Why you chose Bohr model in your research?
Thank you for your question, but I guess there is misunderstanding, because there is a difference between Bohr model of hydrogen atom in quantum chemistry and Born model of solvation.
Okay, thank you.
Thank you, Alexei.
Do you have any ideas of how it can be applied to a real world? Is there an approach to transform this to some kind of non-digital product?
Okay, thank you for your question. So yes, one of the examples is that we are trying to do right now is to apply this method to protein-protein docking. So essentially, you are trying to predict a three-dimensional structure of protein-protein complex, and in that case, you have to sample different possible mutual orientational conformations of two proteins with respect to each other, of course, and for that you will have to calculate those accurate Born radii in order to be totally, accurate. Yeah, for
Okay,
example,
so this is just a method of like of production of some kind of chemical, right? I mean, it is.
No, yeah. So, for example, protein-protein interaction. Yeah, for example, it might be productions of chemical, but I was talking about protein-protein interaction. So that's more about biology. That's more about I don't know. That's more about, for example, antigen-antibody interaction. That I mean, immune system response.
Okay, thank you.
Mm-hmm.
Right, comments now. First, it's about the time. So you kind of have to stick to the time limit. So during your actual exam, it is going to be 10 minutes. So 8 minutes, and rehearse frequently, practice frequently. Okay, to make sure that you're within the time limits. It's kind of crucial. And another thing, it's about body language. First of all, I should say that you demonstrated a good hand gestures. That's a really good thing. You might want to keep it, right? And on the negative side, you might want to do something with that looking up thing. So when you think about how to answer the question, you look up. So you might want to replace it with looking into the camera or at the speaker, right? That's not very drastic, but you might want to change that. Right. Another thing. It's about the structure again. All right. So that introduction, body, and the conclusion. So you might want to have a tighter structure. So you did the conclusion, which is good. Okay, but including the introduction, the introduction that reflects the contents of your presentation would also be a plus for you. So you might want to do that. Another thing is that your slides are very busy. Could you share your screen and show the presentation again, please?
Yeah, sure.
From the very beginning.
Yeah, sure. 1 second. Mm-hmm.
Right, could you go to the second slide, please?
Yeah, sure. By the way, here's the introduction. So I guess I missed the plan.
Yeah, that's the introduction. Well, under the introduction, well, it's highly recommended that you provide the plan for your presentation. Okay, like what you're going to talk about. Now,
yeah, but I forgot to mention. Yeah.
Right. So if we take a look at this slide, you would see that this slide can be easily broken into 3 separate slides. Okay.
Mm-hmm.
So like, yeah, basically it's 3 slides. So like the plan, how can we efficiently pre-calculate all Born ready, and molecular modeling of solution. That's number 1. And number 2, the bold part, the part in bold is kind of wordy. So you might want to try to, go ahead.
But it's an accurate formulation of the thesis. So I'm not sure that I can miss any part of this sentence.
See, the thing is that it's a presentation. It's a slide. You can use it as a prop. You can use it as a helper. So you can formulate your thesis in your speech, but you might want to include a shorter version of that for like as an anchor for your listeners. Okay.
Or maybe split it.
You could, yeah. That'll be a good idea.
It's hard for me to imagine more succinct version of this. Okay, I understand.
Yeah. let's take a look. How can we efficiently pre-calculate all Born radii for all possible mutual orientations of the complex of two or more morally flexible solid molecules? Okay, first of all, you could lose how can we efficiently, and you can lose anything in the end after orientation. So that will be like a very, very brief expression of your thesis. All right.
Okay,
So
but the crucial moments is moderately flexible.
Okay.
Well, no, okay, but no, I see your point. I guess the best way is to split this thing into several parts. And
Totally, because you know that slide contains like way too much information. Right. And could you go to the next slide, please?
yeah, sure.
Yeah, once again, as far as I understand, I'm not an expert. I'm a linguist. You know, I'm very, very far away from your field. But as far as I can see, there are two pieces of information here again.
Okay, again, split.
So you might want to split that. Right. Yeah, this one. Could you go to the previous slide, please? The question in the end, you might want to put it onto a separate slide.
Okay.
You know, it would draw more attention to the question.
But again, essentially I just repeat the same question again and again.
Yeah. And yeah, this is basically all. So please try to have like one piece of information per slide. Keep it very primitive and simple. Okay, you don't have to use complete sentences. You can say complete sentences, but like use that as a base for your speech. Okay, and don't forget about the structure: introduction, body, and the conclusion. With the introduction, you say what you're going to say. Okay, you provide your thesis, and after your thesis, you give the plan for the presentation that you're going to deliver. And you actually deliver your presentation, and with the conclusion, you repeat, you say what you have just told the committee. Okay? Right, I don't have any other questions. Comments, questions, please. Ask me questions.
No, that's, I mean, I understood. Essentially just about splitting and about being within the time limit.
Right, try not to make your slides very busy.
And about looking straight at the...
Yeah, you might want to do that. I understand it can be difficult because that's how people think, but try to do something about it.
Okay, I see. Thank you.
Right, thank you so much. And Alexei has excused himself for 10 minutes. And I understand, Artur, you're going to be the next one.
Okay, no problem.
Yeah.
Unfortunately,
Artur, excuse me. Hamna and Sergey, please listen, take notes, and be ready to ask questions. Artur.
Unfortunately, I have no camera on my desktop.
Well, we will have to go with what we have, I understand. So,
is it a problem with me? Is it problem for me on tomorrow exam?
well, actually, you are not going to have an exam per se. I will just give you a grade because you have only had like 4 classes so far, and I don't believe that it would be fair to grade you after 4 classes. So I will give you grades based on your attendance. So 4 classes, if you have attended all the 4 classes, you're getting 4 points, which is A. Okay, if you have attended 3 classes, you're getting B, and so on.
Okay, I'm ready to share the screen.
Okay, go ahead.
Do you see?
I do.
My workspace, okay. Just a second. Do you see my presentation?
I do.
Okay, guys.
Yep.
Okay.
Yeah, we can see.
Mhm.
My research topic is improving the accuracy of industrial robot manipulators. Step one, because too many steps in my research, and it's very big. We are talking about step one today. Next slide, it's problem and solution. The current stage of development of flexible automated production is characterized by widespread introduction of industrial robots for performance basic technologies operation, as like welding, assembly, painting, laser cutting, milling, and so on. They require good dynamic performance, high accuracy of entering a given position, high accuracy of control movement, availability of means of adaptation to environment, as well as availability of automated programming system. The problems, two big problem in this, it's a high accuracy of entering of a given position and high accuracy of control movement. Solution to the problem, it's three steps in this part. It's a checking of ability of correct the position of the work tool. Work tool, it's a tool. For example, we will talk about cutting machine, about milling machine. It's a milling tool. And second, it's a create a mathematical model of the manipulator. And third, it's creating a tool that will make relevant change to the software. We can call it calibration. And in this part of our project was based on the article of Albert Nibula, Absolute Calibration from robot ABB using a laser tracker. General idea using a laser tracker when the robot is movement, and we can show how change body of robot under force and without force. For this experiment, we using special robot cell in our laboratory. It's for example, it's a rotation table, it's a compressor, it's a force torque sensor, and base plate robot, and it's a typical. Okay, next slide. And in Curie equipment, what we need to make experiment, it's equipment for the fixing laser tracker sensor. You can see these parts. It's a coil for the laser tracking sensor, and when we can put some weight on the robot, and robot have deforms, and we can look on on that deformance from laser tracker. For example, equipment was shows the robot deformation under external force. The idea detects the robot deformation when the robot working under load, and build a robot model based on experimental data. Experiments currently underway. Data from them is used to create and validate mathematical model of the robot. Checking the ability. First step, it's a milling complex shape slot on aluminum plate. First step, we create the program. After that, we create milling and analyze this milling with laser tracker. After that, we build the graph who shows that circle in this part of graph is not correctly. And we build next graph with actual tool path and ideal tool path. And we saw, all all values of deviations of at each point of the trajectory. After that, we build, we create new program with with new values, and after cutting, we we get detail with ideal circle. It was it means that our theory about that we can correct moving the robot and can correct cutting trajectory, it's true. It's very important. It's first step of our experiments. Next step, it's a mathematical model. Right now, we can some experiments about that, creating experimental data, but today we're not talking about that. Thank you. Questions?
Thank you. Guys, questions, please?
Yeah, may I ask you?
Yeah.
May I ask you, do you have some kind of reference point at the on the very tip of the robot, so you can track it using your laser tracker?
Yep. If you see, can you see my presentation?
Mm-hmm.
In this graph, you may see reference point. We can change reference point from 1 in second to 1,000 in second.
Mm-hmm.
We can change if we build more reference point. We get more accuracy graph,
Mm-hmm.
but it's very long to mathematic model.
No, sorry again. My question is more about tracking about the technical aspect of your work. How do you track the very tip of your robot using laser tracker? Is there any kind of, I don't know, reference point there? Is there any marker?
Yep. In this slide, we can see the equipment for the laser tracker marker.
Mm-hmm.
It's like a steel sphere with glass pyramid inside the sphere.
Mhm.
And laser tracker looks at the sphere and triangulate its position with accuracy 0.001 millimeters.
Okay, thank
And
you.
Arthur, I will quickly ask question, then I will have to leave because like it's
okay.
Sure, sure.
I don't have any question regarding the technicalities, but just would like to know, are you doing this project in collaboration with industry partners?
I understand your questions. No, it's my idea. It's my personal project, and we have some project with another project with collaborative, but it's personal project without partners, but it's new technology because if we can uh, if we can make the robot with high accuracy more than today's robot, we can create new cutting machine more more I don't know in English. It will be cost not of lot money.
Okay, I understood. Thank you very much. And I will have to leave now.
That's
Thank
okay,
you
sure.
for your,
Thank you.
okay, goodbye.
Goodbye.
Bye, thank you.
Bye.
Right,
Uh,
so yeah,
Short question.
yeah,
Yep.
go ahead.
As I understand, this technology of can be used for any kind of robot, not only the KUKA robot. Or any.
Yep, general idea.
Is it universal? I mean, to the model.
Yep. It's a general idea that we can use this technology on all industrial robot, not not collaborative robot, only classical industrial robot.
So they all lack the needed precision, right? In terms of the work you are going to do, then they aren't accurate enough. All of the robots on the market or robotic hands. I don't know how.
Can you repeat?
Are all of the models now on the market? They lack the precision you need for your work. I mean, is it common thing that robots are lacking precision and accuracy? I mean, and you should apply such things.
Guys,
Or
I'm not,
I understand the idea. I mean, as I understand the idea, the accuracy of robots isn't enough, especially if they hold something, right?
yeah.
My idea was: is that just a particular robot which isn't enough, which doesn't have enough precision or accuracy, or is there all robotic hands on the market they have the same problem?
Okay, understand you. Yep, you are right. All industrial robots have problem with accuracy because, for example, accuracy of these robots it's 0.5 millimeters. It's not accuracy. It's repeatability. But we try to build the model whose the model it's to model for possibility accuracy 0.05 millimeters. It's enough for the mostly operation in modern factory.
Okay, thank you.
Okay, thank you so much. Now, comments. First of all, I would like to say that I really like the how shall I put it, the slides. The slides, they're based on pictures, figures, and so basically, Artur, what you did was to provide visual support, and then you spoke about your slides, thus making it potentially more interesting for your listeners to listen to your presentation. Now that's a very good thing, and be sure to keep it. Okay. Right. Now, could you go to slide 2, please? Right. So this slide has got the same trouble. It has got 2 pieces of information cluttered into one. The structure of every point is very good, okay? But you might want to split problems and solutions into 2 different slides.
Okay. Okay.
Yeah, and another thing about this slide, so under problems, you've got accuracy. Okay, I don't really understand that accuracy is the problem. The problem is the lack of accuracy. The problem is that you do not have enough accuracy.
Yes, I agree.
So probably the problems is lack of accuracy. Right. And could you go to the next slide, please? Yeah, this one.
Outside sources.
Yeah, you might want to lose the URL because it's really long. It will be practically unreadable. And I mean, I don't really see the point for that slide at all. So you might want to lose that slide altogether, because basically what you're doing in this slide is mentioning a researcher. Okay, so you may safely do that orally without a visual support. So basically, this slide does not do anything, so you don't really need it. Right. Okay. Yeah, another thing, if you forget what you're going to say, okay, if you need some time to collect your thoughts, if you need some time to remember what you're going to say next, okay, so if you need to buy time, you can just repeat the sentence that you have just said. Okay, it will buy you some time. Okay.
Okay.
Right. And please don't say phrases like "I don't know something."
Okay.
In English. Okay. So basically, the committee will not know what you don't know. Okay. So please don't tell them that you don't know. Don't make their job easier. Okay.
Okay.
Don't say that. Another thing is the pronunciation thing. So you've got numerous pronunciation mistakes. Okay. You might want to look into it. So could you say оборудование?
Equipment.
Yeah, that's equipment. Pay attention to that. Could you say точность?
Accuracy.
Yeah, that's accuracy. The first syllable has to be stressed. Accuracy. Could you say сфера? Шар.
Sphere.
That's sphere.
Sphere.
Yeah,
Okay.
PH is F. That's sphere. Could you say идеальный? Could you say идеальный?
Ideal.
That's ideal. Thank you. Could you
Ideal.
say траектория?
Trajectory.
That's trajectory.
Trajectory.
Yeah. See, could you say технология?
Technology.
That's technology.
Technology.
Yeah, CH in Greek words is always K. So technology.
Okay.
Right. Please pay attention to these words because your presentation is potentially very good, but those pronunciation mistakes will will ruin the impression. Okay.
I know about that because I'm learning English only 1 year.
Yeah, that's pretty good result for 1 year, I should say.
Thank you.
Right, but anyway, what I'm saying,
Mm-hmm.
when you get ready for your exam, double check all the words, okay?
Mm-hmm.
Pay special attention to international words, like
Mm-hmm.
trajectory, trajectory,
Mm-hmm.
technology, technology, okay?
Okay.
Right, and another thing, you need to practice a lot, okay? So at least 5 times, practice your presentation at least 5 times because you lack practice,
Okay.
okay? And because of that, you sound monotonous,
Mm-hmm.
all right? You might want to add enthusiasm to your presentation. It will make a good impression on the committee.
Mm-hmm.
Okay, because you know the committee will have to listen to a lot of people during the same day, all right? And if you go monotonously, the committee will be bored, and that will not help you with your grades. Okay.
Okay, thank you.
Right. And yeah, I don't have any other comments. Please ask me questions.
No, I have no questions. Thank you very much.
Okay. And I understand we've got the last presentation for today, Alexei Grigoriev.
Yes, yes, I can start.
Yeah, guys, please listen to Alexei and be ready with your questions. Alexei, you can start.
I'm sharing the screen now.
Okay.
Can you see it?
I can see your screen, guys. How about you?
Yep.
Okay, cool.
Okay,
Alexei, you're all set.
okay. Just trying to understand. Oops. Sorry, I'll be presenting now, not in full screen mode then.
All right.
Okay, I would like to start with the idea that forest monitoring is very important nowadays, and one of the important part of the forest monitoring is monitoring regenerated canopy areas on satellite images. Yeah, I'm doing research on this topic, and partners of my research are 2 companies in the US, the Sierra Pacific, which is the largest timber company, and their information partner, Land Information Services, which create GIS systems and systems to keep track of the forestry for them. Yeah, my project aims are identification of the regenerated areas and markup of such areas on satellite images. They are currently, these tasks are currently made in manually by specialists of Alpine Land Information Services in their GIS software. Yeah, I'll continue with after identification of such areas. I need to continue with finding inoperable areas inside them, because some of such regenerated areas contain inoperable areas, which are populated by some rare species or which are filled with timber which is not operable. Then I need to monitor tree growth on the regenerated areas. Yeah, I didn't mention that regenerated areas is artificially regenerated areas when you replant trees after they've been gathered. And the last task will be to monitor the quantity of merchantable timber on the area. Yeah, I was given an input data with some small amount of images from the Oregon state, which are 19 images, and a set of prepared polygons indicating regenerated areas as shape files, which are just the coordinates of the polygons. Yeah, I did some data preparation for that. I've prepared images with masks based on the polygons, and I've sliced the bigger images to smaller one to utilize pre-trained weights and pre-trained networks on the data set. Yeah, and yeah, that's the idea of what I got with alpha channel marked green. And I've tested several networks, convolutional neural networks types and parameters. And currently I'm using the UNet network with extra levels and batch normalization levels and dropout levels. Yeah, I'm using the Jaccard coefficient to prepare a loss function. And yeah, currently I've achieved, you can see the results of segmentation, which are quite good. You can see these areas, they're artificially repopulated, and these are naturally canopy areas. So yeah, and the upper image represents the original markup, and the lower image represents the artificial intelligence results of the markup. Yeah, the accuracy is close to 98% right now, and I'm doing my best to achieve even better accuracy. Yeah, so my next steps in this task is to improve markup altogether with Alpine LIS. Yeah, to prepare the markup for individual trees, because we don't have any kind of markup, only the field gathered data, which are gathered from UAV or manually using the mobile phones. Yeah, I'm going to try the region-based fully convolutional neural networks for individual tree segmentation then. And I'll try others, regular computer vision algorithms, because there are some for tree top identification, because usually tree tops, they can be glimpsed from satellite images of high resolution, because they have different parameters in terms of spectral analysis. Yeah, that's basically all I wanted to tell you, and I would appreciate the questions.
Okay, questions, please.
Yeah, may I ask you? You mentioned that you use a pre-trained network. So where did it come? I mean, where it comes from?
You mean the pre-trained weights?
Yeah. I mean,
where they go?
If I'm mistaken,
Yeah. There are a bunch of VGG networks in the open sources which are pre-trained of the satellite data.
Okay. You mean standard? Those are available open source, so it's not.
Yeah. They are open source. Yeah, and actually, like for you see, there are two ways to analyze the satellite data currently. You either use the patch-based methods, when you extract small patches and use some kind of pre-trained networks which can understand such patches, like and you can use the fully convolutional technique, like and I tried both. And in my case, with my data and my markup, the pixel-based methods, which are based on usually on some kind of fully convolutional networks like UNet, they provide better results. Yeah, and it's generally because I have the markup like polygons, and they cover like the areas I need on the satellite image. Usually the markup is like a big set of small squares which mark up, smaller areas. So I'm lucky with the markups. So this is one of the precursors of getting the good results on the segmentation test. Okay.
May I ask you one more question? Is it enough data to not overtrain your network? Because I'm not sure. How many pictures do you have right now? 16, right?
I have 19 pictures, which
sorry,
are
19.
quite big in
Those
size.
are very, those are
Yeah, they are big, but still, yeah. There's both subject for overfitting because I got actually this small region, and I saw regions because of the data, you know, they don't allow me to use all the data they have, and probably after like getting some understanding of the results and after using them, they will be able to give me more data because for example here there are some like regions where there are still snow on the satellite, and I've seen them, so they'll probably be more difficult to segment. But yeah, I mean, it's the general idea. If the more data you have, the less over fitting you'll have.
Thank you.
So yeah, I guess that currently I'm a bit overfitted to this kind of region I have.
Okay. Okay, I see. So do you want to? So do you have any plans? How do you want to resolve this issue?
Yeah, I'm currently I'm currently presenting the results to them, including that we've implemented the Python in their GIS, the Python console in their GIS system, and yeah, we'll be trying to ask them to give us more data. Yeah, since that's all this data is proprietary and it's a property of Sierra Pacific, which is kind of very conservative company, which main purpose is to harvest timber. It's not a very easy thing to do, but still we are going to extend our data set. I guess that after getting first results, because actually a lot of time is spent currently just to mark all new areas on satellite images which were clear cut. So since the US government monitors all the new clear-cut regions every year, they just need to populate these polygons with new areas, and this is kind of very hard, very time-consuming task. Not very hard, but a very time-consuming task, which is currently done manually. And probably with the help of this network, we'll be able to help them to lower their costs, and that will facilitate the project.
Thank you.
Thank you so much. Thank you. And comments now. First of all, it's about the structure. Alexei, please stick to that structure: introduction, body, and conclusion. With your presentation, there was no conclusion. So with the conclusion, you have to repeat the basic points that you talked about.
It should be after the next action slide, right? After.
Yeah, it has to be after. I mean, you don't have to have a separate slide for the conclusion, but it would help, and you will absolutely have to speak about the conclusion. So after you finish your presentation, you have to give a very brief overview of what you've been talking about. Okay, that is conclusion. All right, Alexei?
Okay. Yeah.
Yeah, so this is vital. So the reason why we're asking you to do so is well, the basic communication law. So with any piece of communication, good communication is ensured when you first give the preview. So when you tell what you're going to speak about, then you actually tell your listeners so, and then you give the overview. So you tell your listeners what you've just told them about. Okay, so please bear that in mind and go with that structure for your real exam. Okay.
Okay.
Right. Another thing you might want to look for that R sound. Like in the beginning of the presentation, you did that a lot, and that is usually a sign of not enough practice. So basically, you kill that sound when you practice. Okay, a good idea is to record yourself and to look and to listen to yourself. If you hear that sound, you have not, you have probably not practiced enough. Okay.
Okay.
Another thing, you've got all that pronunciation mistake. Could you say точность?
Accuracy.
Yeah, that's accuracy.
Accuracy. Yeah.
Yeah, the first syllable is stressed. Another thing, please pay special attention to the construction there is, there are. Okay, because you have to pay attention to plural or singular form after the construction. Like, for example, you said there are a bunch of trees. Actually, there is a bunch of trees.
Sure.
Because you're speaking about the bunch, which is singular. Okay, and you also say there are still snow. Snow does not have plural, so there is still snow. Please pay attention to that, okay?
Yep.
Right, could you go to the project aims slide, please? Yeah, this one. Right, the second point, oh, the first point first. The first point contains like 2 items. You might want to split them, like identify regenerated area, that's 1, and mark them on satellite image, that's 2. Okay, and you might want to lose the part in brackets. You might want to say that. And about the second item with this slide, inoperable areas identification inside the regenerated areas. So if you take a look at all the items, you would see that every item starts with a verb, but the second one starts with an adjective. So you might want to replace identification with identify. Like what you do, what are your aims? To identify areas, to mark areas, to identify inoperable areas inside the regenerated areas. Okay? Right, right. Could you go to dataset preparation, please? Yeah, this one. Try to avoid passive voice as much as possible. Like masks were generated and added to images. So basically you did that, right?
Yeah.
So use first person. So instead of, it's always preferable to use first person. So first person is preferable to passive voice. So you can use first person like I to show what you did, okay? But you cannot show the first person to express your opinions, okay?
Sure.
Yeah, another thing about that slide is do not use in order to. It's worded. So lose in order, just say to use. All right?
Yeah.
Could you go to the next one, please? Next one, please. Yeah. Yeah, this one, next actions. The last 2 items, try region-based FCNN for individual tree segmentation. So that for individual tree segmentation, this is a perfect example of ineffective nominalization. So basically, for individual tree segmentation, you're showing the aim, the purpose, the why, okay? So instead of saying for individual tree segmentation, you might want to say try region-based FCNN to segment individual trees. Now that will make your sentence easier to understand. And the same thing for the last item. So instead of saying for treetop detection, say to detect treetops. Okay?
Okay.
Right. Okay, I don't have any other comments. Please ask me questions.
So my main question is that I mean we were discussing all these things like passive nominalization in terms of the writing, and this is they are actually important both for academic writing and for presentation, right? I mean, if you write something, and you assume that someone will read it, you shouldn't use that, only in oral.
Basically, yes, because you know, nominalization is quite a dangerous thing because it violates the natural order of processing natural languages. Because like the inbuilt sentence structure is subject, verb, and object. Now that structure can be seen in any language, okay? But if you use nominalization, you replace the verb with a noun, which can confuse the listener, which makes your listener take additional special efforts to understand what you're trying to say. So therefore, you might want to avoid nominalizations. So basically, a nominalization is a verb in disguise. There is no point for you to disguise verbs. You want your words to be clear for your listeners to understand you well. That's the reason. Alexei?
I see, yeah. Thank you.
Right, ask me some other questions. Right, okay, if you don't have any other questions, that was your last class. And you will be giving grades based on your attendance. And I understand I will see you next time at your exam. That'll be next year, I believe.
Okay.
So if you don't have any other questions, that will be the end of your class. And yeah.
May I ask the additional questions? So you will be one of the member of committee, right? Of the committee.
Don't really know. This year I am, and chances are that next year I will be too, but you never know. You know, it's next year, so things could change. But for the time being, I am.
Mm-hmm. Okay.
And the form of the exam will be like there will be speech, like the public speaking part, right? And there will be tests, or
there will be no tests. You will have to write a research proposal. You will have to hand in the research proposal 2 weeks before the oral examination date. That research proposal will be graded, okay, and then you'll have to do the speaking part, which is going to be the presentation. All right, so you will present in pretty much the same way you did today, and you will get 2 grades, like the presentation grade and the research proposal grade, and then you'll get the total grade, which will be the combination of those 2 grades.
Okay.
Did that answer your question?
Yeah,
totally. Please ask me some more questions.
Yeah, last question for me.
Yeah.
Just to, I guess you've mentioned it before, but just to maybe clarify. So, do you know approximately when exactly we will have this? I mean, we will have this exam. Will we have
well, unfortunately, that's a mystery for me.
Somewhere it will be autumn, right?
Yeah, somewhere next autumn. But once again, this is up to the PhD department to decide. So I wouldn't be able to tell you.
Okay, thank you.
What other questions have you got?
None.
Okay, if you don't have questions, I understand. That'll be the end of the class, and goodbye.
Thank you very much.
Thank you.
Thank you.
Thank you.
Bye.
Bye.